Hello everyone. There were a few things that we didn't get to cover yesterday. So that's what I'm going to do in this video. It's fairly small stuff, but should be covered. So one of them, we talked about database normalization, like we mentioned that it existed, but we didn't go into it. So that's what I'll start with. So yep, database normalization. What the heck is it, and why should you care? So it's basically a technique of structuring your database in a way that there's no redundant data, and the columns and tables are organized such that the data dependencies actually make some sense. And why should you care about this? Because you don't want to have problems when you're inserting data or updates or deleting. And I already saw some examples, like if you have two users in our user table that are repeated, and then you want to update the email, you need to make sure that you update the email in both entries and not just in one of them. Otherwise, when you actually want to send an email to that user, you don't really know which email to use. Also, if you delete it, you want to delete both entries and not just one, probably. So don't have like repeated entries. Can start with that. Anyways, there's like quite a lot of these normal forms, which are basically the rules that you must follow. The most important are the first three, and those are the ones that I'll cover here. Okay, I guess I got ahead of myself. So, yep. To do this database normalization, you follow this set of rules that we call normal forms. And as I just said as well, the most important ones are the first three. So, example, you have a table with tasks and users, a bit like what we have in the class. And again, you see that you have 4 tasks, and then you have Donald Duck doing 3 of them, and then the email shows up 3 times and the phone shows up 3 times, and you already know that's not a good idea. So the first normal form, rule 1, each column on the table should not contain lists of values, it should only contain single values. So for instance, this assigned user should only contain Donald Duck and not Donald Duck, Scrooge, whoever. If you remember, that's how we came to linking tables when we had one user doing many tasks and one task being done by many users. Rule 2, each column should store only values at the same time. So if you have a column like create a date where you should store dates, then that's dates that you should store there, not integers, not strings, not anything else. Database management systems like MySQL in general do enforce this. You cannot store an integer if you say that the column type is a varchar, so a string basically. But there are others that don't really do that. Once I use SQLite, and I found myself storing an integer where I should be storing a string, and that didn't go very well. So just keep an eye on it. Rule 3, in a given table, a column should have a unique name. So it shouldn't have, like in the same table, 2 columns named title, for instance. Sounds pretty obvious, right? And again, I guess it's the kind of thing that MySQL and Postgres and so on enforce. Like you cannot just do that, they'll get confused. Rule 4, the order in which you store your data shouldn't matter. So it doesn't matter if Donald Duck shows up on row 1 or on row 5, you should get the same results when you're looking up something. And yeah, I think this was it for the first normal form. For the second, what the rule is that there should be no partial dependency. So let's first say what is dependency. So if you have this user table and we select a user using the user ID, then we get the name, the email, and the phone. So what this means is the name, email, and phone for a given user depend on the user ID. They're associated to that number. If I look at user ID number 1, I'll get all the information for Donald Duck. Then partial dependency is basically when you have a primary composite key. So yesterday we saw that for a linking table user task, we could either have a primary key that would be the ID column, or we could just take both the user ID and the task ID, and their combination would be a primary key. So it would be a composite key because it's composed by 2 columns instead of just 1. Anyways, partial dependency is when there's one column in your table that only depends on part of that composite key. So an example, we have here again a user table and then a tasks. And then imagine that we have our user task table at the bottom, but we have the user ID, we have the task ID, and these are our composite primary key. And then you have the status for that task, for that user, because maybe for instance you have user 1. This is not a great example, but you could have 2 users working on the same task, where one user already did its part of the task and the other didn't. So you could have a status that actually depended on both the user and the task ID. But then there's this other column where you have a role, so whether the user is a developer or a student. And this column in particular, it only depends on the user. The user ID is Donald Duck is not going to be a developer for one task and a student for another task, in this case. It will either be always a developer or always a student. So this kind of information should be on the user table. And definitely, not having a column that only depends on part of the composite key. Then third normal form, the rule is that there should be no transitive dependency. And what is this transitive dependency? It's basically when you have, you have composite key, I believe, student ID and subject ID together are your primary key. And then you have the marks that you get. This is an exam table basically. You have the marks for the subject and the student. Then there's the task type that was evaluated. And marks is the same as grades, by the way. So if it was a weekly assignment, a project, or an exam. And then there's this column that basically says what's the weight of the task on the performance review. And the thing is, this task weight depends on the task. It doesn't depend on the student and the subject. So it's like a transitive because task type depends on student ID and subject ID, but then the task weight only depends on the task type. And it should be depending on the primary key, this task weight. So the solution here is you create a table where you have, I called it exam table, but I guess it would be more like task table, where you have the task type and the task weight together, and then you could just get it. So you'd have a task ID as well there, I guess, as a foreign key. So these are the 3 normal forms. These slides are on the GitHub repository in lesson 2. In the branches for class 12. So you can always have a look again. What else do I want to talk about? Indexes. So that's something I also skipped. And let me start my SQL. Oops, I'm not sure if it is it. Go away. So use href lesson 2. Select all from user. And like when you're selecting information or just looking for it in general, like there's no specific order. So if I want to select a user where name is like heavy for a change, my SQL probably just goes like entry by entry until it finds heavy. And if you have a million rows and heavy is the last one, it will go through all the million rows until it finds heavy, which doesn't sound very efficient. So if you have a database where, and a table in particular, where you usually look up, for instance in this case, usually look for the name and not for the ID of a given user, what you can do is to add an index to that column, to the column name, because it's a column that you're going to use very often to find users. And what the index does is basically like it orders the names like in alphabetical order, for instance. And when you're looking up someone, like you can just do this. I always forget what the name is, but the idea is that you can like divide the table in half. You see what's the name in the like half of the table. So in this case, like what's the name like in entry 6, which is roughly half. And if you see that it starts with a letter that comes after H, then you'll go and look up in the first half of the table, because it knows that H comes before M, so you go and look there, and then you divide it in half again, and if the letter that shows up, the first letter in that entry is again higher or lower than H, if it's higher, you go to the second half and try to look up there. If it's lower, you go to the first half and you try to look it up. And this doesn't sound very clear, I'm guessing, but maybe if I do where name user order by name, maybe if I do this it makes more sense. So I'm looking up for heavy again, right? I'll divide the table roughly in half, and I see that the name I get starts with a P, heavy starts with an H, that comes before, so I'm going to look in the first half of the table. Again, I divide it in two halves, I check the entry in the middle, starts with a D, so I know that heavy must be in the other half. I have these two left, and then I can find heavy straight away there. So instead of looking up every single entry, I'm just doing this thing of dividing the table in halves, because I know that it's ordered by the name. In general, by default, I think the ID is the index, and I think I can check the index by describing the table. Maybe not. So let's see what I have on indexes here. Okay. Maybe I should Google. Always MySQL. Okay, that sounds good. Show index from user. Yep. So if I run this show index from user, I can see that ID is indexed in the user table. So it will be super fast if I'm looking up a user by its ID rather than the name. But if I want to create an index column, I can do that. Let me check the syntax. I'll post these links also after the video. Oh, where was it? So just copy paste. So the syntax is create index, I need to, whoops, oh, this is a bit weird. This is the name of the index. You basically give it a name, so I can say user name on the table name, user, and then name. And I can specify actually like I can just say name and the whole name will be indexed, or I can say that I just want to use the first 2 characters of the name to do the indexing, and that will make things faster. And if I now show, yeah, I see that in the user table I have 2 indexes now, ID and name, and then in the subpart you have in ID it's everything, in the name it's only the first 2 characters. Now I might ask, why don't we do this for all the columns? Well, first it will be a mess to have everything ordered when like already ID and username are a bit weird, because I mean you're ordering by both and they're not really compatible. If you look here, like when the name is ordered, the ID isn't, and the other way around. The other reason is to keep things ordered, like when you insert data, it will take longer because it needs to insert it in the right position rather than at the end of the table. So you need to think like, what's more important for you? To access the data fast or to insert data fast in the database? And of course it depends on your specific case. So yeah, if you want to access the data fast, you create an index on the column that you typically use. If you want to insert the data fast, you don't create indexes. So what next? This was it for indexes. Okay, now on column types, there was one thing that I forgot. I forgot to tell you about the enumerations. So there's, let me get again the code for creating the database from yesterday. So you have when you create a column, you say which type it is. Like for instance, this one is text. Text can be super long. But you could say that, I don't know, if you have a table with clothes, for instance, and clothes have a size, and the size is typical like there are predefined sizes. Like for instance, if it's a t-shirt, the sizes are, for instance, extra small, small, medium, large, extra large. So only if you want only specific values on your column, you can use an enumeration type and say only these values are accepted. So again, let me go and check out the syntax. It looks somehow like this. So if you wanted to create a table for shirts, you could have the name of the shirts in varchar, that's fine, and then the size would be, the type would be an enum, which is basically an enumeration, and the allowed values in that column would only be extra small, small, medium, large, extra large, and that's it. If you want to play around with that, feel free, enjoy. This was it for enumeration. Yeah, and I'll also post this documentation page about it. A bit more serious stuff, complicated values to store in MySQL. So if you're dealing with prices for your t-shirts, for instance, and you have like different data types. So I'm going to open the numeric data types here. You have, for instance, integers, and we've already seen that integers are all fine. Then for decimal numbers like 2.3, we have different options. You have like floats and doubles, which you probably already know from JavaScript, and then you have decimals and numerics. And well, from JavaScript you know the floats, and you probably go for that obvious choice in MySQL. The issue is that floats are not like really exact numbers, they're like approximate, and sometimes you see weird stuff. Let me try to show you something. Like in Node, if I type 0.33 times 3, you'd expect to get 0.999 with 3 nines, right? But you don't. You get a 1 at the end. So you cannot really do like precise arithmetic with floats, or at least not always. So the way you solve this problem in MySQL is, instead of using floats to have prices, because you don't want to do like summing prices and then they get a weird result there. A result that is not accurate in general. So what you do would be to use, where is it right now? Decimals, the decimal type. So for instance, here I'm declaring the salary. When I create my table, I'm going to insert this in my shirt example. I don't even have a primary key here. Jesus. ID int 10 and signed, and this will be my no auto. Let me copy this. That's too pragmatic sometimes. Okay, not the salary, but the price for the t-shirt. And basically what this means is that when this decimal with these arguments, okay, so yeah, your price is type decimal, and then 5 is the total number of numbers that your price have, and 2 is the number of decimal places. So you could have something like 33.23 to 1, and this representation is exact. If I would take, well, in this case, in this price, I have to do this, but if I would do 0.33 times 3, in this case, I would get this. So yeah, if you're dealing with prices, please use decimal or any other number that you know it needs to be exact. What else? Storing dates and times. So yesterday I totally went over like the date time for our created column in the tasks and updated. Also the due date is a date time type, and I kind of forgot about this. And the thing with its time is, there's time zones, right? So what you want to put, if you have users in different time zones, or in this case tasks that were created in different time zones, which time zone do you want to use to store the date when it was created? To make matters even cooler, you have two different types of columns in MySQL to store dates and times. You have the date time and the timestamp, and I'll go into the difference in a bit. But bottom line, one idea to not get confused with time zones would be to always store date times in UTC, so the universal time coordinates, and then you, like when you want to tell the user the time when the date was created, if you want, you can, like in your JavaScript, do the conversion from UTC to the time zone where that user is. So anyways, the difference between date time and timestamp. The difference is when you're using date time in the field type, like for the created dates, whatever you put in there, that's also what you see, and it doesn't care about the time zone of your system or anything. The timestamp, however, it does care about the time zone where you are. So what it does is, you give it something, it converts from that time zone to UTC. The time zone of your system. And then when you retrieve it, it converts it back from etc to the time zone where you are. This sounds a bit confusing, and it is a bit, but let me show you an example. So I'm going to start my SQL. I'm going to create a database. Pop, create database, time, date, time, example. Yep, I think I had some code somewhere here. Oh, yeah, somewhere. So I'm going to create this table, timestamp versus datetime, where I have a column with times in the timestamp time type, the column for datetime in a datetime type. I'm just gonna run this. Of course there had to be an issue. What am I doing wrong? Oh, I forgot to comment that. Auto increment equals 1. What the heck? Anyways, let's give it a shot again. Tada! And if I describe my table, oof. Yep, I have 3 columns: ID, timestamp column, datetime column, with the respective times. And now I'm going to say that my time zone in my SQL is the same as my system, which is etc plus or minus 1. I never know these things, but you can Google it. So yep, I just did this. And now I'm going to insert some values into my table. I'm going to add these dates: 1st of January of 2020, 10 in the morning, 10 minutes, 10 seconds. And I'm going to insert the same in both columns. And yeah, that's it. Now if I change the time zone to actually etc and insert the same data, so far so good. But let's select from select all from. I need to copy this. So everything at first glance it looks fine, but if you actually look at the column for the timestamp, the first entry we added when we were using the time zone of our system, we see that the timestamp, the time is 9 in the morning, and in the datetime column the time is 10 in the morning. So basically the datetime kept the time that we actually inserted there, while the timestamp adjusted to our system's time zone right now. Like so, my system's time zone is apparently, let me double check, Copenhagen local time, and it will usually tell me exactly UTC plus 1. So when I set the time zone to the system, I was in UTC plus 1, which if I say it's 10 in the morning, when I change the time zone to UTC 0, so no offs, no differences from the real UTC, it will be 1 hour less. So my timestamp is now, it shows up 9 in the morning. The one in the bottom, because I'm still in the same time zone, UTC, it shows also 10. But yeah, in the daytime it always shows the same thing that I inserted. It didn't change the representation at any point. If I now change again my time zone to the system, I'll see the first entry will be at 10, but then the second entry in the timestamp will be 11, because my system is etc plus 1. When I created this, I was at etc 0. So now when I look up the value in that entry, it adds 1 hour to match 10 in etc, but like to become what the time is in etc plus 1. So it adds an hour. So yeah, be very careful with timestamps and date times. The time is probably the safest thing. What you put in is always what you get. Then if you want to do conversions for different time zones, if it's like, just do that on your JavaScript code. If you think it's important to store the time zone in the database, that's also fine. But yeah, be very careful with timestamps. And if you have any more questions about this, probably Kalpen is the person to ask, because she has experience with this, I'm pretty sure. So yep, I think this is it for tricky values to store in MySQL. Yeah, be very careful with prices and date times. Now on to SQL injection. Some of you have already asked about this, and it's basically what happens when you have like raw queries, and then you can insert data in the website in the search field, for instance. You can add some comments and some things, and basically have new SQL commands, and they run in your database, and basically just the things that you don't want to happen. So for instance, there's a small example that's framing this. Let me see if I find it. So this is on lesson 3 of the class 12 homework update adapted or something. Anyways, you'll get to play with it if you want. And there's a readme, so there's basically like, another SQL injection example, and then there's a readme for you to see how to set up everything, which I'm actually gonna check, because I think it's just npm run to start it up. Yeah, actually npm starts. So npm starts, and now I'll go to my local host for 3000. That's where it's running. And yeah, I like this very basic form to do a login, where I should insert my email and my password. And the thing is, I can insert my email, and I can so the queries probably look like something like select from user, well, where email equals whatever I give it, and password equals whatever I give it as. So here on this, check out what I'm gonna do. So I'll close the quotes after the email, and then I'll say, where email equals this, or 1 equals 1, and this sentence will always be true. And then I finish the statement in MySQL with the semicolon, and I add this dash dash as a comment. It's very important, the space afterwards, by the way. So basically this query will become something like email, I need some copy pasting. Something like this. You see what happens? Like, my password can be anything. So let's see if I can log in with just a random password. Yes, I'm logged in, because email equals this, or 1 equals 1 is always true, and then the rest is commented out. If I didn't have that, if I just had the email and put a random password, I cannot enter. The email or the password are incorrect. So this is my SQL injection. And if you want to look at the code itself, it's here. It's in this server file. This is Node code. You'll probably be able to read it better in a few weeks. But the bottom line is like we're doing the query like raw, very raw. But there's other ways of doing it better in Node, especially where you can basically escape your values, like so things like the dash dash are cut off, this or thing goes, like it's super cool. And there's different ways of escaping things, and there's one like better than the other. I'm not going into details because you have Node. And also you'll be using Connects in the project, which does a great job at escaping things. That's also why I usually use libraries to interact with databases. There's two big advantages. One is this escaping of parameters that you pass to your queries, so like your email and your password, to make sure that there's no SQL injection. And the second advantage is also that the way you interact with the database is the same regardless of the database management system you're using. You just need to change your configurations and it will work on MySQL, on Postgres, on SQLite, Microsoft SQL, whatever you're using. So yeah, and also there's a quick link if you want to learn more about escaping SQL statements in Node, which is like another lesson through 3 materials. Yep, there's the example that I just ran, and yep, there's like this. The other thing that you can do is and that's probably something that is already done widely, is to adapt like the permissions for what people can do, for what users can do with your database. So for instance, so far we've had all the we've had permissions to do whatever we want in our databases, read data, add data, delete data, whatever we want. But you can actually configure that for each user independently. So you can have users that can only read data, for instance. Still, they might read more than you would like to, but you can do that. And you can also say like, hey, I want this user to only read entries from this one table in this one database, and that's it. And the way you do this is by using this grant stuff. Where am I? So I'm going to use I can stay on this database, and of course I need to look up syntaxes, but so I'm going to create a user and give it only specific privileges. And where is it? State archer. Yep. So again, I'll then post the link. But where is the stuff to create the user? Why did it go? So give me just a second. Here it is. Sorry. So, for instance, I'm going to create this. Oh, way too fast. Okay, why is this being a bit stupid? So I'll create a user, not Jeffrey, but Martha. My password will pass. So I'm basically here using the syntax create user. Martha at localhost. Localhost is basically the server, which is my computer, so it's localhost. And then identify by pass. It's just my password. And then I'm going to grant some privileges to myself. So, for instance, if I want to grant everything, on a certain database, I could run this. So grant all, you can do everything, insert, delete, select, whatever, on this db1, and then dot tables name, so all tables, because it's an asterisk, it's like everything, 2, and then the user. So I'm going to actually only run select permissions to myself. So Marta, and what did I call this database before? Date time example on dates time example, and there's only one table, but I'm going to specify the table that I'm granting privileges to. So I'll grant select privileges on the database datetime example on the timestamp versus datetime table in particular to mark.localhost. Clearly I did something wrong. It's telling me that this table doesn't exist. Okay, what? I'll go with all the tables. Okay. Did I show grants? So if I do show grants, I get the privileges for myself. I'm the root at localhost, and I have all the privileges. And I think I can say for user as well, for like Marta. So I need to say Marta at localhost, something like this. And then I can see the privileges for Marta, and I can see that do I have all of these? Probably not. I'm going to log in as Marta though. So MySQL minus u user Marta minus p pass. And I'm going to start by trying to use database from yesterday. And I can't. I don't have permissions for that. Because I only gave myself permissions to read data from that datetime example database. So I already forgot what the database name was. Ooh, Jesus. Did I even? Was that the name of my database? No. Oh, so I messed up. I gave myself permissions to a database that doesn't exist. So let me change that. So that's the datetime example. So you see, I could only see this information schema database as Marta, the user that I created with specific permissions. Let me exit, go in again. Now I can see the time example, see? But I cannot see anything else. If I'm as root, let's see how many databases I can see. Quite a few. So, yep, I'll use that. Datetime example. I'll do a select from, oops, maybe I'll show tables. I can only, I cannot even see tables. Did I myself somewhere? I can swear that I did this like half an hour ago and it was me. Tables. Yeah, I can see everything now. Oh, I'm the wrong one. Oof! Smart me, I created a database, forgot to change to it, and so everything is in HYF lesson 2. Always double check what you're doing. Okay, so I guess I'll grant myself permission also for that one, so that I can actually do something. HYF lesson 2, and Yeah, that's why it wasn't finding the table. Now it makes sense. Okay, so now in the HIF lesson 2 database, it's the database we created yesterday. Apparently I also created this timestamp versus date time table there. And now Marta can only see this table in the HIF lesson 2. So let's change database here as Marta. Just restart to make sure that it's all fine. Use HIF lesson 2. Now I can, if I do show tables, I can only see one do. I cannot see, like I saw here, the status, the task, the user, and the user task tables. So now if I do a select from there, I see things. Let's try to insert. Let me copy from somewhere what the code was. Yeah, this should work fine. Let's try. Error. Insert command denied to user Marta.localhost for table. Because I don't have permissions to do this. Because if I show grants for Marta, I see that I have permissions to the timestamp versus date. Select permissions only. Press select. Timestamp versus date time. Database. All tables there, but there's no tables there. Actually, this is not even a database, so I should remove this. Date time example for again this database with all tables, but there's no tables there. And then I granted myself permissions for the HIF lesson database, but only for this table with timestamps and date times. And yeah, I cannot access other tables, I cannot access other databases, and I cannot insert values anywhere. So that's also a way of adding security to your database. You only let users do specific things, like for instance only reading data, not inserting or deleting, for instance. And I think that's it. Yep. So briefly we went over normalization of databases. Important to avoid issues when you're updating rows or deleting. We went over indexes to make your searches faster, if that's a priority. We went over enumeration date types, just so that in each column you can only have specific values. For instance, the sizes of t-shirts are predefined. Then we used over like tricky values to store in MySQL or any other SQL database for that matter. Like the prices, should use decimal to store prices because it's a precise format. Dates and times, be very careful because timestamp always adjusts what you get with the time zone of your system. Well, date time gives you always what you put in. So maybe use that and use UTC as a default time zone. Yeah, then we went over security and SQL injection. So a tiny example of how it can happen. That's also why you use specific libraries to deal with SQL so that it can get rid of most cases of SQL injection for you and you don't even have to worry about it. And then we also went over permissions for database, like the things that each user can actually do in a given database. And that's it. If you have any questions, just post them.